What we have here is a partial spreadsheet. We see a table on this side and numbers across the top, and some numbers down the side here which are for entry. What it all means is we have a catchment outlined across the top there. So much rainwater catchment per month, the total on the left in liters. Our percentage of catchment is about 14.5% of the catchment. Our percentage of demand is 14.5% of the catchment. We have lines in the graph down below that show the volume of the tank as it's set, and the number of users creates the demand. In this case, it's only for flushing. There is no garden area, so there's no demand for irrigation. So from the catchment area and from the efficiency and from the monthly rainfall, we can calculate what the harvest will be. In this particular case, we have about 85% of catchment is going to overflow. The rest is being used for flushing. There is no subsidy required. There's no red on the graph at this stage. And we would normally adjust first the size of the storage to make up for any problems we saw with the graph, but since there are no problems, we don't have to make any adjustments there. We can see that our level line of demand goes pretty much steady all the way through. We can also see from some of these numbers that about 75% of the rainfall is between October and March, and 25% through the summertime. This is in Hilliers outside of Qualicum Beach. We're using Environment Canada data norms from 1971 to 2000 to figure this out. So we have two users in this case, and like I said, normally we would change the volume of the tank or the size of the tank to adjust. Right now we'll change the number of users and still see that our 500 liter tank will manage things. The volume of the tank has gone almost to the bottom, so we're just about using up everything that comes into it. When we go to 6 users, we see that suddenly we have about 3,900 liters of subsidy required in the months of July, August, and September. We've used up all the overflow and we're still running a little bit short. Now we could increase the size of the tank to match that. We're almost there. We've reduced the subsidy down to less than 1%. The overflow has been reduced. We're using it up, of course. We'll modify that one more time. 4,300 liters of tank, and again, this may not be an actual tank size, but it's a number we can use to start working from for the design of our system. We've basically got our subsidy down to just about zero, and that's the place you want to be for optimum. If, on the other hand, we used up all of our overflow, we would know that would be the maximum size of our tank. We couldn't get a bigger tank. It wouldn't do us any good. We have 260 square meters of catchment, 2,800 square feet. We're at 90% of efficiency. We have no garden and no irrigation. We have 6 users, and we're only using this for toilet flushing. Now there's an alternate version here that's been modified for drought. And April, May, June, September, October have been reduced, and July and August eliminated as far as rainfall goes to represent the year 2015 here on Vancouver Island. First ever major droughts that we have that they've been experiencing here. So this represents a drought year, severe drought year. There's a reduction in the overall catchment. You can also see some drastic changes in the distribution of the rainfall, where the summer is now down to 7% and the winter has the other 90+% of rainfall. We're still using the 90%, the 260 square meters, 2 users, but it's 8,250 liters of storage that is required with this scenario, this rainfall scenario, that meets the demand that we had before. That's 2,145 US gallons, 1,800, 2,000 imperial gallons, something like that. I'm going to go to 4 people. We have increased by 15,000 and some the requirement for subsidy. We still have lots of catchment going to overflow, and so we know that we have room to enlarge the tank, which we'll do, and we'll put in 23,500 liters, and we've used up most of the of subsidy. We've taken care of it. We still have overflow. Almost 60% of the water is still going out to wherever it goes. In this case, it's out to the storm drain. It could be into a rain garden or some other beneficial use. By increasing the size of the tank, we've reduced the subsidy. We're almost at zero, so we're pretty representative of what's required. You can see there the tank level line, and that all of the overflow is used up in that section. We still have 60%. We could go to more people. Just to note, this blue is rainfall, the dark blue is overflow, the brown dash is the demand line, the blue dots are the full line in the tank, and the dashed line at top is the actual size of the tank. So at 6 people, again, we have gone into subsidy required, meaning we have to increase the size of the storage, capture more of the rainfall and overflow, and we're at about 45,400 liters. We're just about 80 liters off of zero, and that's about where we want to be. We don't want to put in a larger tank than that because it would be useless. We couldn't use or change the chart anymore by going to 46,000 or 50,000 or 100,000. It just wouldn't make any difference. So on the chart part, we're able to see what's happening with the numbers. We're able to change things, and everything works together.